talking about matrices. Welcome to my channel. Matrices was first introduced by Authur Kelley. I know it may not seem important, but yeah, it's good to just know. This was a British mathematician, and this was the first person to introduce matrices. So a matrix is a rectangular array of m number of rows and n number of columns. First of all, you know that it is a rectangular array. Okay, array just means arrangement of m number of rows. So rows are like this way. Okay, now we have this m times, okay, and then n number of columns. So these are columns straight up. Okay, you can see that the vertical lines, the ones that look like your y-axis, are the words columns. Okay, and there are n amount, m number of rows and n number of columns. So let's move on. How do I name a matrix? So if I'm given a matrix, let's say this matrix, how do I name it? I just need to count the amount of rows, which we have seen as m, and then count the amount of columns, which is what, n, and then I have what, an m by n matrix. This m by n is called the dimension of the matrix. So now we'll be looking at types of matrices. There are various types of matrices. So in this video we'll be covering some of them. So we have the column matrix. Column matrix is just having one column. Okay, so how does a column look? It looks like this, your y-axis. Okay, it looks like this. So you just draw a rectangle that has only one of that, and as many rows as possible, So an example of that is something like this: 1, 2, 3. Another example: 7, 8, 9. Another example: 2, 0. And then a special example: 0. And that one, 2. This is also your matrix. If you look at this matrix, it has 1 row and 1 column. Row matrix simply has 1 row. Okay, so you can write as many entries in 1 row. So that leads me to defining what an entry is. So an example, first of all, is 2, 1, 5, 3. Even that special one is also a row matrix. So moving on, what is an entry? An entry is simply a member of the matrix. So if you have a number inside the matrix, for example this is an entry, this is an entry, this is an entry, and this is an entry. Now, just as we have names, entries have name. So how do we name? We name it. If the matrix is called A, is equal to, say, 2, 1, 3, 4, 1, 5. Okay. We name this matrix simply A is equal to, okay, the entries of A, which we have as 2, 1, 3, 4, 1, 5. The entries of A are simply called A. The position of it on as in number of row and the number of columns. So you can see that the number of this row is 1, but the number of this column is also 1. Okay, so the number of this next one is what we have. The number of this one is what we have. What that entry is in the first row, but is in what this column is called the second column, and this is 2. So that's the second column. In the second column, what do we have? We have it as A1 2. Okay, the next one is what? A1, yeah, it goes right, 3. Then we have A2 1, A2 2, and A2 3. Good. Now that we've gotten a hang of that, if I ask you now, what is A1 2? What will you say? You count 1. Good. So that's first row. So we are looking for the second element in the first row. The second element is what? 1. This is the second element in the first row, because it's on the second column. So we have A1 2 is equal to 1. You can do this for as many elements as what possible. So just count the number of rows it is on, and then the number of columns at the same time, and then call it. So always know that row comes before column. So we can call the row I and call the column. We will have that A is just a set of AIJ m by n times. Okay, so if I keep plugging in AIJ m by n times to get the rectangular matrix, I'll get back my matrix A. Okay, we have next type of matrix is a square matrix. In a square matrix, we have number of row equals to number of column. Okay, number of row equal number of column. So is that easy? If you count the number of rows and they are the same with the number of columns, what do you have? You have a square matrix. So if your m by n matrix has m to be equal to n, then you have a what? Square matrix. So instead of calling the square matrix m by n, we call it an n by n. An example of a square matrix is, say, B, matrix B. I'm just naming the matrix. This is like just the name of the matrix, just like you have your name. Just like I'm Joan, matrices also have names. So let's call it a 3 by 3 matrix. Okay, so we have B is equal to 1 3 4 5 minus 6 2 8 1 minus 7. Yes, so seeing this now, we can see that the entries of a matrix can be negative. Okay, so entries can be negative numbers. Okay, for example, what do we have? We have minus 6 and what? Minus 7. There are two negative numbers here. Okay, so before we wrap up this video, let's check out equality of matrices. When are two matrices said to be equal? Two matrices are said to be equal if they have same dimension and what? They are equal entry by entry. Okay, corresponding entries are equal. So these are the two things you check. What do I mean by dimension? I mean what? M by n, same number of rows and the same number of columns, and if and only if the entries, their corresponding entries are, if two matrices, say A is equal to A11, A1, A21, A22, and I have B to be equals to B11, B12, B21, B22. A is equals to B if and only if. Okay, this is how we represent if and only if in math. Okay, so if and only if, what happens? They're equal corresponding elements. Okay, so I have what? A11 is equal to B11, A12 is equal to B12, A21 is equal to B21, and A22 is equal to B22. So in general, it implies that what? Aij is equal to what? B ij. Now that we are through with that, let's quickly go to taking a few examples on algebraic examples. We can have normal examples. Okay, so but most of the time we get algebraic examples using one matrix to get the other components of the other matrix. Okay, remember they must be equal corresponding entries. The entries must be what? Their corresponding entries must be what? Equal. So let's take an example before we round off. So what do we have? We have find P plus Q, given that what? Given that P3 5Q is equal to 7 3 5 minus 4. So let's solve this. So what do we have? We have P plus Q is equal to what? What is my P? This is my P. So it must be corresponding to that. So we have what? 7 plus. What is my Q? This is my Q. So I look for the element there, and it's exactly this point, minus 4. So 7 plus minus 4 is what? 7 minus 4, and that is what? 3. And we are true. That's our answer. So thank you for watching my video. Please subscribe, give this video a thumbs up, like, share, and I will really appreciate it. If it has helped you, please share it. I really want more viewers. Yes, thank you.